Welcome to Spring LIB.
In this exercise, we're going to be talking about circular motion. So before solving the problem, I'm going to briefly review the topic. So when we have a particle that's undergoing circular motion, the acceleration of the particle can be decomposed into two components. One of them is the centripetal acceleration, and the other one is the tangential acceleration. The centripetal acceleration accounts for the change in direction of the velocity and is equal to v squared divided by r, and is present even if there is no change in speed of the particle. The tangential acceleration, on the other hand, accounts exactly for the change in speed of the particle and is equal to the derivative of the speed with respect to time. So this is what we need to know in order to solve our problem. So what we have is a man that's lying on a cushion, and the man is 8 feet separated from the z-axis here, and he starts to rotate around the z-axis with a speed of 20 feet per second. The cushion makes an angle of theta, which is equal to 60 degrees with the horizontal. The man has a mass of 150 pounds. And given this information, our goal is to find what is the normal force that the cushion exerts on the man, and also what is the frictional force. In order to find these, we need to draw a free body diagram. So this is the man. The forces that act on the man are the gravitational force that acts downwards. We also have the force that the cushion exerts on the man, that's the normal force, and the frictional force. Notice that if there were no cushion, the man would fall to the ground. So the frictional force is pointing upwards. This here is 60 degrees. This here is 60 degrees as well. So now let's decompose the force into two components. One of them is the y component that points upwards, and the other one is the x component that points to the left. And actually, instead of calling the y component, I'm going to call it the z component because I want to be consistent with the axis I presented before. So in the z component, the forces are n times the cosine of 60 plus f times the sine of 60 minus mg is equal to 0. So instead of writing like this, I'm going to sum mg on both sides. In the z component, we have n times the sine of 60 minus f times cosine of 60, and this is equal to the mass of the man times the centripetal acceleration, which is v squared over r, as I said before. And our goal is to find n and f, so we can isolate them in this equation. Notice that we have two equations and two quantities that we want to find out, n and f. So I'm going to solve these equations for n and f. Actually, I'm going to call it ff. So what I'm going to do is to multiply the first equation by the sine of 60 and the second equation by the cosine of 60, and then I'm going to sum them. Notice that in this case, the f component cancels out, so we're left with n times cosine squared of 60 plus sine squared of 60 is equal to mg sine of 60 plus mv squared over r cosine of 60. Actually, I'm sorry for that. There's something wrong here. I should have multiplied in the inverse order, so I should have multiplied the first one by cosine of 60. That's correct. The second one by sine of 60. So sorry for that. Now the second term cancel out, and we have mg times cosine of 60 plus mv squared over r times sine of 60. Okay, notice that this here is equal to 1. So we have that n is equal to mg cosine 60 plus mv squared over r sine of 60. So n is equal to the mass, that is 150 pounds, times g, that's 32.2 feet per second squared, times cosine of 60, plus v squared, so that's 20 feet per second squared divided by r, which is 8 feet, times the sine of 60. So the normal is equal to 276 pound force. In order to find this, actually, I need to divide the force by 32.2 pound times feet per second squared per pound force. So n is equal to 276.7 pound force. This is the normal. Now we can find f. So for example, I'm going to take the first equation here and isolate f in the equation. So we have that f times sine of theta is equal to mg minus n times cosine of 60. Okay. So we have that the frictional force is mg. mg is 150 times 32.2 minus n, which is equal to 276.7 times cosine of 60 times 32.2, and then I'm going to divide it by the sine of 60. And from this, we obtain that the frictional force is 13.4 pound force. Okay, we have to divide it by 32.2 pound feet per second squared per pound force. And this concludes our exercise.